Hi, my name is John Newman, and I am a security system engineer here at Cisco. Today, we're going to talk about tetration, specifically the beginning and understanding of the physical and virtual footprints needed. As a quick reminder, tetration ingests and analyzes traffic from your network. Now, we have options out there that can see north-south traffic, such as Cisco StealthWatch, Next-Gen firewalls, but tetration specializes in seeing east to west traffic, specifically in your data centers and clouds between your application workloads. We're looking for three things: to control communications, system behavior, vulnerability detection. Using sensors on your applications as well as in your environment, tetration provides unmatched visibility in any public, private, or hybrid cloud environment. This allows us to analyze system behavior and see how systems are supposed to be acting together. Tetration is able to automate policies to help microsegment applications and help control communication. Continuous monitoring of these policies and system behaviors help us with the vulnerability and threat detection. So let's take a look at tetration's deployment models. So tetration has four different deployment models at this moment. Three are considered on-premise models, and then we have our software as a service option. Two models are physical form factors. So we have our large form factor, which supports up to 25,000 workloads or 2 million flows per second. It does have built-in redundancy, and it does come with a 39 RU rack that is in either one or two rack options. We'll talk about that here in a minute. Our small form factor, or our small physical form factor, can support up to 5,000 workloads or 500,000 flows per second. This does come in a 8 RU rack form factor. Our virtual appliance will support up to 1,000 workloads or 70,000 flows per second. It is software only, and that hardware is supplied from the end user. And the software as a service, it can scale from 100 up to 25,000 workloads, and the entire infrastructure is owned by Cisco. So the physical footprint of the single rack large deployment of tetration, as you can see here, we have one spline at the top with two leaf switches, an open section, 16 compute servers, 8 cache servers, 12 base servers. It does require 4 three-phase PDUs, and it does peak out at 22.5 kilowatts. Overall, this whole piece weighs 1,800 pounds. Now we can look at the dual rack, which is essentially the exact same piece except for split. All the numbers are going to be split. Each rack does require its own 4x 3-phase PDUs. Again, 11.25 kilowatts per rack, totaling the same as 22.5, 900 pounds per rack. But we have the exact same switches on each. We have a spline and a leaf on rack 1 and just a leaf on rack 2, and the actual servers are split between them. So our medium footprint, this is going to be a little bit different. We have 2 leaf switches installed on it, but we have 6 universal servers. So they are not dedicated to be specific appliances at this point. So coming into the virtual appliance, Cisco Tetration is a software only for a virtual appliance, and it does work on VMware vSphere. So this does use your own server and storage infrastructure, but it is a very simple deployment process. We deploy it off of a single orchestrator within your own environment. This allows us to spin up faster, and you can see the benefits and the value of tetration very quickly. It is suitable and designed for up to 1,000 workloads. So let's take a look at the actual specifications. So we do require 128 physical CPU cores with a minimum of 2 gigahertz clock speeds. This is all assuming that it's not hyper-threaded. We do require 2 terabytes of RAM, so our virtual machines can consume up to, or are expected to be consuming up to 128 gigs. So we do recommend to have more than that for those. And the memory cannot be overcommitted. So we also require 18 terabytes of storage. So this storage needs to be high performance, such as flash or SSD, and capable of a minimum of 5,000 input-output operations per second. Of course, storage needs to be accessible from all nodes. It, it needs to be provisioned as a single shared VMware vSphere data store. We do support pieces such as Hyperflex, NFS, iSCSI, and more. Of course, it needs to be durable, and we do require that 18 terabytes. So Tetration in total does consist of up to 54 VMs, and we are a software sensor for telemetry collection. So we do not support any of the hardware, so there's no 9Ks. Again, we scale up to 1,000 workloads for the virtual. So looking at those actual sensors, these are going to be the requirement for the sensors. We do have 3 different OVAs at this moment in time. So we can see that we have the ingest, the edge, and the export. They do require 8 to 32 CPUs, 8 to 64 gigs of memory, up to 350 gigs of storage. Now, when we get into the NIC section, that's where things change a little bit, where our ingest do require, on some of the sensors, 3 NICs. Our edge and export only require one NIC. We can see the number of connectors that we need is between 1 to 6, depending on the piece that you're running. And when we come into the actual Dockers, our ingest will be spinning up 3 Dockers on some instances, and our export will be spinning up to 13 Dockers. So those 13 Dockers consist of 10 instances of Logstash, 1 instance of Elasticsearch, 1 instance of Gargana, and 1 instance of Curator, which is our retention model. So these used to be split into multiple OVAs depending on the sensors that you wanted. They are now combined for simplicity, but we'll get more into that in a bit. So a quick note for the Cisco Tetration software as a service. Again, this is no hardware to be managed by the end user. Everything is fully managed and operated by Cisco. It is a very low bar to entry, very quick to spin up, so you can see that value very quickly from Tetration. So let's talk a little bit about the actual virtual appliances. We're going to walk through the virtual install, some telemetry, and then finally the requirements of it all. So this is going to be the actual initial virtual install to get everything up and running. Exact details of this can be found on our install guide on cisco.com. We do recommend that you host the orchestrator OVA on a web server close to the ESX cluster. It can become a very large file, so depending on your infrastructure, it could take a while if there's a slow link. But to start, we're going to install the orchestrator from the OVA, accept the default configurations of it, and the first gotcha comes around when we're actually mapping the networks. So we do require 3 networks. The first one's going to be a configuration network. That needs to be a routable network where orchestrator can be reached during the actual deployment phase. It should not be part of your public network, and it will be disconnected after the deployment has been completed. The second needs to be a private network. This is a non-routed network for Tetration internal communications. And finally, we have the public network, which is a routable network where we can hit the GUI collectors and the VIPs. Once we go through all the prompts, finish the install, you can open up the browser to hit the actual GUI. And once you are there, you are going to be presented with a page to start installing the RPMs. So we have to upload the RPMs in a specific order. It needs to be the RPM install, the ad hoc, mother, and then the OS OVA. And then finally, we can go through the rest of the prompts, monitor it, and it'll be about an hour and a half hardware dependent. So a quick note, the orchestrator and RPM files can be found in the major releases of Cisco Tetration on CCO. The other versions will contain RPM upgrade files, and the ingest, edge, and export OVAs that we've been talking about can be found in other versions as well as the major releases. So we've mentioned the ingest, the edge, and the export multiple times, but where do they actually come in? So our software and hardware agents feed directly into our analysis engine. Reminder, we do not support the hardware agents for our virtual machines. All the other traffic, such as our Cisco switches, our F5s, our cloud and AnyConnect, all those are then led to our Docker sensors. And then from the Docker sensor, that is forwarded to our actual analysis engine. Our analysis engine also communicates to our alert notification appliance, which is used for external integrations. And not shown here, redo the slide. So I've mentioned before, or all right, let's try this one more time. So I've mentioned the ingest, edge, and the export multiple times, but where do they actually come in? So for simplicity, on the left side, we can see that we have our software and hardware agents that lead into the analysis engine in itself. Reminder, our hardware agents are not supported on our virtual machine deployment. So as an ingest engine, we can have our traffic coming from F5, Citrix, AWS, AnyConnect. Those lead into the ingest Docker sensors. You can see those on the right side. Then the Docker sensor in itself will send that to the actual analysis engine. The analysis engine will also communicate with the Tetration alert notification appliance that is for our external integrations. And it's not shown in this graphic, but our Tetration Edge platform is used to integrate into platforms such as Cisco ICE. So looking a little bit more at the actual virtual sensor appliances, here we can see that we have the ERSPAN, NetFlow, Citrix, and F5. Each one of those are going to be the ones that contain the 3 Dockers. AWS has 2 Dockers, and our TAN and AnyConnect will only have 1 Docker each. You can see the name of the RPM files. These are going to be pulled from your specific orchestrator. Each of these do have an OVA format on CCO, but it does require an ISO configuration file. We'll talk about that more at the end. So looking at the actual requirements for each one of these systems, we do require between 4 to 8 CPUs, 48 gigs of RAM, and between 40 to 200 gigs of storage. The NICs that come with it are very specific. It does need to be a 10 gigabit NIC. Three NICs are required for the ERSPAN and NetFlow, 2 for the TAN, and 1 for all the others. So how do we get all this actually deployed? So to start, we need to download the Tetration virtual appliance OVA from Cisco CCO. From that, we create the VM and provision it from the specs that we were just talking about. Now, from your orchestrator, we need to download the agent RPM. We can also create, we will be required to create a ipconfig configuration file to contain the IP and gateway addresses for each interface. So in the case of the ERSPAN, we required 3. So in this file, it must contain 3 rows, no more, no less, and no comments. All the interfaces must belong to the same subnet. So optionally, we can also create a host configuration file. If we do not, the default name of it in this case is going to be erspan-vm. We can also optionally create a user config file. This is going to be containing our proxy server settings. Finally, with all that, you create an ISO file, add it to the VM as a CD-ROM, DVD mounted disk, and you finally boot up the VM. With all this, it will go ahead and spin up the Dockers. More information on this, as well as everything else that we had talked about, can be found on cisco.com through our install and upgrade guides, our release notes, and Cisco Live presentations. Thank you for taking the time to watch and listen to this, and I hope we talk again soon.